Okay, welcome to my next video in my never-ending series on free will here. Okay, so I've given a definition of free will, which seems to be by and large accepted, but there are a few holdouts. In particular, Everett says that he wants to see a mechanism in the brain whereby this could like plausibly be. Kids these days, man, always with the mechanisms. Okay, Everett, this one's for you, dude. All right. What I did is I went and I found a plausible mechanism for this in the brain. Okay, let's go over to the chalkboard and I'll diagram it out for you. Remember the famous dome example which John Norton gave. There's a dome of a certain shape that if you balance a ball on the top of it, the ball can just start rolling non-deterministically in any direction at any time. Well, I found that a similar scenario is possible in neurons. I found a neuron type that has a similar kind of behavior. And here's the method I used. Okay, I used basically the same technique which Norton used. All right, he said he found a textbook example of a differential equation which has more than one solution. And then he worked backwards from there to find a physically plausible scenario which was modeled by that equation. So I did the same thing, but instead of using Newton's laws of motion like Norton did, I used a different starting equation and I worked backwards to the Hodgkin-Huxley model of the neurons. Now, Hodgkins and Huxley won the Nobel Peace Prize in 1959 for their development of these equations. And we're still using these equations today. They modeled the behavior of neurons actually quite well. So let's briefly review how this neuron thingy works, right? It's like a little battery. So between the inside and outside of the cell, there can be a voltage that's there. And as you apply pulses of voltage to the input of the neuron can put pulses of voltage in response to it too. So it's basically what I did was I found a non-determinism in how these pulses of voltage work. Right? So here, let me diagram it out for you here. All right. On the y-axis scale, the y-axis scale is in millivolts, and the x-axis scale is time, and it's in milliseconds. Right? So before t equals 0, what we've done is we've kind of clamped this neuron. We've forced it to be at 0 volts. We've grounded the neuron. Then, at time t equals 0, what we do is we unclamp the neuron. And the neuron can now, basically move to whatever voltage it wants to. So between 0 and 1 volt milliseconds, the voltage, it might remain at 0 volts, but at any time t between 0 and 1 millisecond, it could just start ramping up. Quite the same as the ball could just start rolling at any time. There's genuine non-determinism here. Now, the moral that I want to draw from this story is, remember my definition of free will. X is physically free to do A, if and only if it is physically possible that X elects to do A, and that it is physically possible that X elects not to do A. So this physically possible becomes the sticking point now, right? So if we could show that the universe was completely deterministic, my game would be up. It would be physically impossible to elect to do anything else if the universe is deterministic. But what I've shown here is there's really no reason to assume that physical determinism holds, even at the level of describing us as firing neurons. Okay, we can describe human beings on many levels. Atomic level, as a swarm of atoms, and the proper vocabulary there is quantum physics. At the neuronal level, and the proper vocabulary there is the Hodgkin-Huxley equation. At the physical level, you throw somebody out the window, right? The proper vocabulary there is to use Newton's laws of physics. Folk psychology, we treat each other as people with free will and stuff. None of these levels are known to be deterministic. Okay, they might be deterministic, but we don't know for sure that they're deterministic, right? So there's really no reason that nothing forces us to assume that any of these levels are deterministic. So my plans for the next several videos in the series go as follows. Okay, I want to present the detailed math behind this non-deterministic neuron, and it's pretty hairy math, but I think it's important. I want to show how it works. And after that, I want to make some videos on how randomness in the brain, this non-determinism, isn't just randomness in the brain. It can be more than just randomness in the brain. So I want to show that we're not just jerked around randomly by a will which we can't recognize as our own. And then I want to make a sermon on how these various vocabularies that we use to describe ourselves, how they all relate to each other and what we can expect from them. And of course I want to conclude that we actually have free will. So Hope you stay with me.